Hi, my name is Erel. I'm a researcher at the Gilat Research Center. It's the southern campus of the Vulcani Institute. And we are studying avocado response to nitrogen in the past 3 years. Avocado is a major fruit crop in Israel. There's high demand for avocado, especially in Europe, in countries where it's too cold to grow avocado. So avocado is expanding everywhere. And farmers came to us with a question, what can we do to increase the productivity? Although Israel is a relatively warm country, the winter is too cold for avocado and it suffers from frosts and in general from low temperature. Avocado is a kind of fruit tree that is sensitive to everything. If it's too high or too cold or too saline or not enough nutrients, everything will result eventually a massive drop of rootlets, and this is what you see here. And eventually, the yields in Israel are not that high. Even the best farmers don't obtain much more than 15 tons per hectare. Let's say compared to apples or citrus, where we get 40 tons per hectare, or other varieties which are not Hass that can produce over 20 tons per hectare. So our research question was, can we enhance the productivity of the Hass avocado by optimization of the nutrition in general and specifically nitrogen? To answer this question, we started a control experiment in large containers. These are 1,000 liter containers filled with perlite substrate. We have 5 levels of nitrogen from very low, 10 milligram per liter, to very high, up to 120. The 40 is marked in yellow because this is the farmer's practice. These are the recommendations. And we have another treatments that we won't discuss with the higher micronutrients concentration. In between the test trees in the containers, we planted the pollinators, Ettinger. The experiment started early 2019, and it's still running now. So for over 2 years, these plants are receiving these 5 levels of nitrogen. We run leaf diagnosis routinely every October, and we see that the plants very quickly respond to nitrogen. When we apply low nitrogen level, we see that the leaf nitrogen is below what's considered a deficiency or the optimal or threshold by Reuter and Robinson, 2.2, and the leaf and level increases with nitrogen in irrigation. However, from 40 to 120, we don't see much changes. Also in October 2020, there is not much response when we go to the high N levels. And this is very problematic issue because there is huge difference between the plant response between 40 to 80 to 120 milligram per liter. And you can see that visually, the plants, the growth or the vigor response to nitrogen increases continuously up to 80 and then decreases sharply. And I will show it again soon. But this effect cannot be seen in the leaf analysis. And this is a major limitation of leaf analysis. And this is not only avocado, but you can see it here very clearly. We routinely do mass balance for water and nutrients. It's very simple in this system. We have very precise water meter that records every liter that each tree receives, and we manually collect the drainage
So the volume of water that enters the tree minus the volume of water that drain is the evapotranspiration of this specific tree. And the same we can do with nitrogen, phosphorus, potassium, and so on. What you see here is the water uptake of the trees for 2.5 years at the 5 different nitrogen levels. The darker the color is, the higher the nitrogen level is. So you can see that we started with very small trees with very low water uptake, about 1 liter per tree per day. And roughly after 6 months, we start to see that these treatments, 80 and 40 milligram per liter, have higher water uptake. That means that the trees were bigger, so trees transpires more. And we see that the high nitrogen level, the 120, reduces the transpiration after roughly a year. After, in the second year, it's already as low as the N20. At the second year, we reached a maximum of nearly 70 liter per tree per day. And you can see at that specific day, at the beginning of September, the water uptake as affected by the nitrogen level. Again, this is mainly the canopy size, that's it. As I mentioned earlier, we also monitor the nitrogen uptake, and we can see that nitrogen uptake expressed in milligram per day roughly follows the evapotranspiration rate in blue. So it starts with 200 milligram per tree per day up to 1 gram, and then reduced in the winter and so on. But we have to remember that we irrigate at constant concentration. So the more water we apply, the more nitrogen we apply. What I did instead is to plot the nitrogen concentration in the drainage, okay, collected every couple of weeks, throughout the duration of the experiment. And what we see here is very interesting pattern. It's not that simple anymore. We applied to all these trees. Each dot is a single tree in a single time point. We applied 40 milligram per liter, and we see that there's specific times where the nitrogen in the drainage is very, very low. That means that the trees absorb almost all of the nitrogen that was applied. Might say that they were starved for nitrogen. I don't know. So what we see here that in the past 2 years, it's repeatedly in the same time of autumn, winter. In the winter, we apply not a lot of nitrogen because we don't need a lot of water for irrigation, but the plants absorb all the nitrogen, while in the summer, the opposite is true. And this is very interesting. And now we are testing whether we should apply nitrogen in the winter. This is something that farmers do not practice in general here. We also monitor many physiological parameters like assimilation rate or stomatal conductance. And we see, most of the time, we see positive response to nitrogen. So assimilation or photosynthesis increases with nitrogen, not in all the data, also stomatal conductance. What is interesting, regardless of the nitrogen level, we see that we have high assimilation rate in the season, in the summer, June to September, and then it decreases during the winter and then increase again in the spring. High in the summer, decreases in the winter, and increase in the spring. And this is probably related to the environmental conditions. As I said, the winter here in Gilat are relatively cold, but radiation is high, and that's something that causes photoinhibition or radiation stress. And we do see in the winter that the leaves that facing the sun in the morning have bones. This is a very typical symptoms for photoinhibition. So we measure chlorophyll fluorescence, the maximum quantum yield, FV to FM, throughout the year.
And you can see that during the summer, everything is good and normal. 0.8 considered to be a good condition. And in the winter, we have sharp decrease and then recovery through the spring. There is no effect for the nitrogen treatments for most of the year, except the mid-winter, where the low nitrogen treatments have more severe photoinhibition, have lower maximum quantum yield. We also monitor reproductive parameters. So the first thing we see is the initiation of flowering, and we were very surprised to see at the first year that at the high nitrogen treatments, 120 milligram per liter, we see a lot of flowering bud developing at very early stage. Already in December, January, we could see very clearly, as you can see here, the flowering bud, while in what we consider control, 40 milligram per liter, there are still no visual effect. So flowering was developed much faster at the high end level. That's repeated also in the second season. And in general, these trees, the more nitrogen we apply, the trees flowered earlier and faster. But not only that, the question is around April, at spring, how much flowers will I have? And we see that the flowering intensity increases with nitrogen in general. And also we even measured how many flowers we have on one stem, for example, and we see that the number of flowers increases with nitrogen up to 80 milligram per liter, and then decreases at the highest end level. So we also see some positive effect of nitrogen on reproductive trait, which is interesting. We are measuring fruit set. You have to remember that these are very, very young trees, and at this stage, the yield is not expected to be high, but we did have flowering, and we did have very nice fruit set at April. You can see it here. So we have at the first season nearly 20 fruitlets per branch. But this is what we see also in the field. There's very massive abscission, fruit drop during May, and eventually we go, when we reach June, we have very, very few fruits on the trees. But when we see the effect of nitrogen, we see again that the 80 has the best results in 2020. The 40 milligram per liter has the best result in 2021. And in general, we don't see this competition that sometimes agronomists suggest, that too much nitrogen will drive the tree into a vegetative stage over the reproductive stage. That's not the case here. So we have larger trees with higher fruit set. So to conclude, we saw that we have very nice experimental platform that is expected to run for at least another 2 years, and we hope that we will have a significant yield next year. We see that the trees response to nitrogen in an very classic optimum curve. That means that growth and flowering increases with nitrogen up to 80 milligram per liter. And then when we increase further, we see very sharp and massive decrease in growth, in vegetative development. This is very high concentration. As I said, the practice here is 40. I don't want to suggest anyone to start irrigate with double the amount of nitrogen. This have to be tested. I speculate that we might not give the nitrogen at the right timing, and that's the main issue. Maybe we should reduce the amount of nitrogen in the summer and take this amount to the winter. And this is what we said, the plants absorb all the nitrogen in the winter and leave quite a lot of nitrogen to drain in the summer. I would like to acknowledge the funding from the Avocado Board, the Israeli Chief of Science, and the CFPN, the RO and ICL initiative, the students that carry out most of the work, and my lab members. Thank you.